Has this ever happened to you? You're trying to have a fun day on the slopes, and you have to push with your foot to get your snowboard to go where you want to go. This happens to people all around the world every single winter. Look at this guy. You don't want to be like him, just shoveling around in the snow and such. Look at him, he just fell down. Well, luckily, we have a solution for you. This is the Snowboard Propulsion System.
Here you can see the full overview of our system. We have about 50 aluminum-based components wrapped in a carbon fiber shell. Right now you see it in the first and passive stage. Then the user will go ahead and pull that handle, latch it over the locking mechanism, and the fins will be in the snow, where it will then propel you forward by a 400-watt motor.
All of our major kinetic parts have been calculated and designed to uphold long lifespans, as well as have high factor safety values. The AFBMA 16-ball roller bearing used will allow the board to cycle through 113,000 millions of revolutions on average before having to replace them. The paddle wheels and key shaft will only be undergoing 80.8 psi and 75.52 pound-foot of shear stress, respectively, due to this ingenious design.
The spring we designed for this mechanism has a 5-inch deflection with a factor of safety of about 1.34. Its main purpose is to keep the gears meshed while the mechanism is in its active state. Here we can see an animation of the paddles rotating with a 1.5 to 2 and a 1-to-1 gear ratio.
Frictional losses in the gear train were calculated using tabulated efficiencies of spur gears. The frictional loss was found to be 3.96%.
FEA was performed on multiple parts of our assembly, including the fins, the shafts, the gears, the handles, and much more. Additionally, we used the AGMA equations in our machine design textbook for bending and surface stresses for gears to calculate the factor of safety we used for our carbon steel gears. It turns out that the lowest factor of safety we found for our gears is about 1.1, which is shown in the Excel sheet right here.
Our final product meets the customer requirements of fitting within a 10.5-inch square area with a maximum 6-inch height. The product is installed on the rear half of the board, immediately behind the rider's rear foot. This allows for maximum user control and minimum interference with the factory snowboard kinematics. Our design allows for up to a 300-pound user to be propelled up a 3% grade.
Don't be like one of these guys. Get our snowboard propulsion assistant today. It's right, it's light, it's easy, sneezy, mcDeluxe.